Okay, so let's try next coding exercise. So if you open the leetcode.com and go to the problem section, and you could see so many problems here. So we will like explore the problem number third, which is the longest substring without repeating character. It's come under the medium category, but like you can say like it's easy only. So let me remove all this. So let's read the question. Given a string as, so some string has been given. Find the length of the longest substring without repeating characters. So there is a difference between substring. So substring is a contiguous non-empty sequence of character within a string. So substring should be like some without we can't skip some words. So there should be like if ABC or BCA like should be continuous. That we call as a substring, and that substring should not have the repeating characters. As an example, so we have given a string as, so let's s is given, which is some string is given abc something is given. We need to find the longest we need to find the length. So we have to return some integer, like we have to return some integer, that is the length of the longest substring. So we need to find what is the longest substring without repeating characters. All right. So if we start from A, like we will start from A, let's suppose. Then A is itself, then it only one character, so no repeating character. Then we will like proceed with the next character AB. Then length is 2, but there are no repeating character. Fine. Then we will go with the next character ABC. Then like length is 3 and there are no repeating characters. And if we pick the next element now ABCA, but A is the repeating character because A is already in the string. So ABC is one of the substring, but we can't say whether it is the longest or whether it is not the longest because we have not checked the other substrings. So basically we have to check each and every possibility, and whoever is the longest length we are going to return. So as an example, so we have just 3 example, let's suppose. So ABC, ABC, ABC. So here, if we start from here, so ABC is one of the string. Then BCA and B, we can't consider B, so BCA is one of the string. So in this question, ABC is one of the like the longest string. So the length of this string is 3. So similarly, B. So on if we pick B first element, then length 1. Then we pick next B, then we have the repeating characters. So we can't pick that. So only one length, that is the output is B. Output is 1 and the element is B. So similarly for PWWKEY, one string is given. We need to find the longest substring. So we pick first element, that is fine, P, length 1. If we pick second element, W, and it is not the repeating, so length 2. If we pick the third element, it is repeating. So till now we have length 2. So we will pick the next element, W, 1 element. If we pick W, it's 2 element. So we still length 1. If we pick the third element, W, K, E. So all are the non-repeating characters. So we have the longest string, that is the 3. So how to do that? So basically we have to find each and every possibility. So one thing is the brute force solution. We have to find each and every possibility. So how to find each and every possibility? So let's put the brute force method. So this is a string A, B, C, A, B, C, B, B. So what we can do, we will start from the first character and we will check each and every possibility. So we will run one loop, right? So 1 minute. We will start from the letter A, right? So you could see this is yellow symbol. We will start from the letter A. We will keep checking the next element. Okay, the next letter is B. So whether B is already there, no. Then we will check C. Whether C is already there, no. Then we are going to check A. So A is already there. We are going to stop. We will break our loop. So A, B, C is one of the string, and we will calculate the length, and we will store our length into the some maximum length. Let's suppose 3. Then it's broken. So we can't check A, B, C, A. Then we will start from B. So B, C, A, then again B is coming. Then we will again break. So B, C is one of the 3 characters. Then we will start from C, C, A, B, then again C is coming. Then we will again break. So C, A, B is one of the string, which is 3. Then we are going to start from A, B, C. Then again B is coming, which is repeated. Then we are going to break. A, B, C is the longest substring. Then we will start from B, B, C, B, but B is again repeated. So B is the substring which is length 2. So which is like the longest substring as part of this. But we already have the longest substring, so that is the 3. Then CB, then B, then only B. So we have to check each and every possibility. All right. So basically, if we can see, we have to run two loops. One loop is like a outer loop, which will like check each and every element, then other loop, like which is going to break at some point. But if you read the constant is given, the length could be 0 as well. So if the length is 0, what could be the longest substring? 0 only. If the length is 1, what could be the longest substring? That is 1 only. So if length is 0, if the string has no character, then output is 0. If string has one character, then output is 1. All right. So we have to consider that scenario as well. So basically, if length is less than equal to 1, either it's 0 or 1, then we are going to return the length of s. Basically, if string is empty, then return 0, length of s 0. If length is 1, then if like only one element is given, then length is 1, then we are going to return 1 only. All right, so let's try to implement this brute force method, and we will see whether our brute force method is going to accept it in the lead code or not. If it is going to accept it, then we are good, but we will try to maybe optimize it later on. But first, let's see whether our brute force method is going to accept by our lead code or not. So let's try this. So let me copy this and let me rename it brute force method. And so some string is given. So let's pick this string itself. All right. So we will call the function and we will pass the string. It will return some output and we will print that output, like what is the output. Fine. Okay. So what we have to do as part of our like brute force method, we have to run one loop. All right. So we have to run one loop for I in a range of, from where we have to start, from 0, from 0 till which point? Till like a length of a string. So let's calculate the length of the string. So n is equal to length of s until s. Okay, fine. So basically, first element is a. Like then second loop is from b. The second loop, the third loop is from c. The fourth loop is from a, and the fifth loop is from b. So similarly like that. But when we pick first element, then again we have to run one loop. All right. So for I in range 0 to s, then we have to run second loop. For j in range, all right, for j in range, we have to pick from the second element, right? From j in range, from I plus 1 to till n. So here we have to also put the n here. All right. So let's do the pass. We forget one condition, and that condition is if length of s is less than equal to 1, then we have to return length of s. Basically, if it is 0 element, because as part of the constraint, it can be 0 element. All right. So that's why we are covering that condition. And if it is one element, only like a character or b character, then only that is like a substring which has the non-repeating characters, then we are going to return. All right. So if length is 0, then we are going to return 0. If like a string has one element, then we are going to return length of one element, which is 1. So we have covered that condition. Fine. And now let's start. So we started from a. Fine. 1 minute. So we started from a. So like from I in range 0. Fine. We started from, then we have to start from then we pick b. But we have to check whether b is already in the come or not. So how to check b is already come or not? So as soon as any character came, we are going to store. And the best way to store in a kind of a dictionary. because in the dictionary we are like get the elements in just a single operation, O of one, big O of one operation. So for I in range 0 to n from first element, so as soon as the first element occur, we are going to store that element. The element is S of I, and let's like we have to give, because it is a key value pair, then we are going to like say by one element or true, false, or anything. But what is temp? So we have to define that temp as well. So temp is a like empty dictionary. All right. So as we trigger the first element, we store our first element in some dictionary, like S of I is equal to 1. So now dictionary has my like one element, right? Then from J is starting from B. Before storing that element, before calculating the like length, and like we already store one element, and we can check the longest is equal to like 1, because length is 1, because if we store one element and that is unique, because first element at least like length is 1, the longest is equal to 1. So for j in range I plus 1, I plus 1 is the, from the second element, right? So first, before proceeding further, we have to check whether this element is already come or not, because if it is already come, then we are not going to include that. So how to check? So if s of j in temp, right? So if s of j in temp, or we can say if s of j not in temp, to make it easy, if not in temp. So if it is not in temp, so let's suppose b is not in temp, like b is not like come earlier, so what we are going to do, we are also store the b as well into the our like dictionary. So now the dictionary has a and the b element, right? And we are going to increase our length, longest is equal to longest plus 1. Else, if it is there, if b, okay, so let's try to like cover this situation first, like leave the else part. So we will start from 0 to n from a. Okay, fine. So as soon as a come, we will store into a dictionary and make it like length is equal to the 1, because we have to return the longest length, so 1. Then we have to check the next element from b. So second range from the I plus 1, so which is from b. So b is not in the dictionary, correct? So we are going to store into the temporary array, so and length is become c. Then again loop come. So now c, so c is in the dictionary, no. Then again we are going to store the element, and then length is now is equal to 3. Now again came a. So a is in the dictionary, a is in the temp, a is already in the temp, so we are going to break, because we don't have to include the next a. So if s of j in the temp, then we are going to break. All right. And we have to return, so we have to return the max length. So max length is equal to 0. All right, so let's suppose the max length is 0, and as soon as the first loop will be end, so we will calculate the max length is equal to maximum of max length and the longest, like what is the longest, like which calculated till now, and we are going to assign, and then we are going to return our max length at the outside of the second for loop. So let's try to run this, if it is going to work or not. So we get the 3, and which is fine. So let's try some another output, b b b b b. So we get the one which is totally fine. So let's try the another output. So we get the 3 which is also fine. So let's try to submit the solution. It is a brute force. We just run 2 loops, because we don't know like whether the Leetcode is going to accept or not. All right, so let's run this first. So sample test cases has been accepted. Let's try to run all test cases if there is any issue in our code or not. So all test cases has been accepted. All right, even the Leetcode has accepted our solution. But if you see like here, we have beat only 15% of the people because this solution is not optimal. Our solution took 497 milliseconds, even though it is being accepted. Right? Ideally, like it should not going to be accepted because we are running the solution in of big of n square. So big of n square generally not recommended. So, but anyhow, whatever the test cases like Leetcode has given. So how many test cases run? So not sure how many test cases from where to check. So anyhow, like whatever the test cases. So the detail section or no. So we are at here. So only we have beat only like 15.66% solution. But if you see the maximum trends are here only. All right. So let's try to like, even though it is accepted, you can like do with the two for loops, but let's try to optimize the solution. So like whenever any question come for the coding in which you are running two loops and there is a chance that that can be possible in one loop. So only and only approach is the two pointers approach. Yesterday I also like told you like the only two pointer approach. All right. So in this question as well, the two pointer approach is going to work. So let's go to the description again. All right. So even though this is going to work, so let's remove this. So sorry. So we are going to write another function. So def length of longest substring optimal method, which is a string and is going to return the integer. So we will write and let's print here as fine. We have to write the code. We will see like first we will see like how we can optimize it because here are two loops. So if you have in any question, if you have to minimize the two loop, now just think about the two pointers approach. And that two pointer can be start from the first position as well or first or last position as well because it is a substring. So definitely that both the two pointers are going to start from the first position, not from the first and the last, because it's not like that because we have to see the non-repeating. So definitely we can't put one pointer here and one pointer here. All right. So let's try to optimal solution. So one condition is we know already. So let's try to write that condition, which we already know. So if length of s is less than equal to 1, we have to return length of s, which is totally okay because if string is empty, then we will return 0. If string is 1, then we are going to return 1, which is fine. All right. Okay, so these two condition has been done. Now we have to optimize. Right now we are running two loops, two for loops. All right, so we have to optimize it. As soon as we optimize it, we have to minimize into one loop. So we have to use the two pointer approach. So we have to run the two and the where we have to two pointer. So definitely we have to start one pointer on the first position, definitely, but where we put the second pointer because it is the substring kind of thing and non-repeating. So second pointer is also at the first position. We can't put the second pointer at the last. Like in the previous question, we put the second pointer at the last. It's not like that. We have to put the first, like both the two pointer at the at the starting position. So L is at 0 or R is at 0. Fine. And till when we have to run the loop generally. So when L is when both the uh, pointer reaches like exceed our length, so we have to run some loop when the both the pointer are shorter than my length. All right, because if it is exceed my length, then what we have to check? Nothing, because it is out of array. All right. So how to check? So let's suppose first pointer is here, and because we will keep one pointer and we will move our second pointer. Right. So let's suppose L is our fixed, and then we are going to move our second pointer. All right. So if L is fixed, so let's suppose L is at A and R is at A. All right. So our current pointer is current element is S of R. S of R is A. Okay. So we will take an empty dictionary because we have to check, because anyhow we have to check whether that element exists in the previous element or not. So how to check whether this element exists or not? So we have to store the previous element somewhere. So we need dictionary. Similarly, same concept we are going to use. We need some kind of dictionary. We are going to store those elements. All right. So we need some dictionary. Okay, scene elements or temp or any like by any name you can define. We have to like, so current element is S of A, or fine. So first we check whether this element, current element, which is A, is already exist or not. So no, it's not already exist. So we are going to store our current element. All right, so we are going to store our current element. So right now we are storing like this by one in the previous question, because we have to store like by one. We have stored by one, true, false, or anything ABC, something by, we have to give a value, because in the dictionary we have to give the key value pair. So just ignore this, like, but we are like, why we put R here, just ignore this. Just make sure we are storing that element into the dictionary. So we have stored that element like A0 something, right? Okay, then we have stored that element, then we will increase our right pointer. All right, because this element is not there, then definitely we have to increase our right pointer. All right, so we have to increase our like right pointer. So here, 1 minute. So L is at A now, R is at B now. All right, so now we will check. So current element is S of R, which is B. So we will check, okay, whether B is in the existing elements or not. In the scene elements, or in the scene elements, it's A of 0. So B is also not there. Okay, totally okay. So we are going to store our B as well. And we will increase our length as well. And we are going to increase our right pointer. So we have increased our right pointer. So now the right pointer is at the C. Fine. Now we are going to see whether we have not moved our left pointer, right? Till now only we are moving our right pointer. All right. So now we will check C. Whether C is in the scene elements? No. So we are going to store our C and we will increase our length. So length is now 3. Okay, fine. Now we will move our right pointer A. Right now, right pointer is at A. So we will check before storing into the dictionary. We have to check, because we will only store those elements which were not in the scene list. So before storing, we will check whether A is in the like array or not. So not array, but in this our dictionary or not. Yes, A is in the dictionary, but at which position it is? All right, so at which position it was? So it was at 0 position. That's why we are storing here. Whenever we are storing the elements, we are storing the position here. Even in this case as well, like, you can store the position. It's like I am storing 1 here because there is a no use of the position, but you can store the position as well, because we have to store some value. So here we have to use this position. That's why like we are storing the position as well. So the next element is A. So we have to, before storing that element, we have to check whether A is in the previous scene elements or not. Yes, A is in the scene elements. A is 0, B, C, B1, C2. A is here. A is already here. So A is at which position? A is at 0 position, right? If A is at 0 position, what we can do is we will increase our left pointer. But like, where we have to put our left pointer? So we have to put our left pointer 0 plus 1. All right. So from to the next position, whatever the next position is B. So we are going to put our left pointer at B. So we are put our left pointer at here. So basically, so now, so L is at here. All right. And now R is at here. All right. Now we are going to store our R, like A is already there. We are just going to update its position. Now A is at like 0, 1, 2, 3. So A is at 3, B is at 1, C is equal to 2. All right. Now again we are going to increase our pointer. So now R is at C. All right. If R is at C, sorry, if A, B, C, sorry, R is at B. So whether B is in the previous list, yes, B is in the previous list. So B is at 1. So we will increase our left pointer by L plus 1. So now our L is at C and R is at C, and we will update our index of B. So we are going to update our index of B. So similarly, we are going to repeat and repeat and repeat. And how we are like, as soon as like something break, like as soon as we found some element, and we have to calculate the length. So how to calculate the length? R minus L, like right minus left plus 1, and the longest is 0. So whatever is the maximum, we are going to show it to the longest. So let's try to like implement this logic. And we are running only like one loop here. Just we are increasing our both the two pointers. All right. The same concept is being using, just instead of two loops, we are using two pointers. All right. So let's try to implement. So this is done. So in starting, we have to take two pointers and both the two pointer at the 0 position. All right. And like let's calculate the length as well, length of S. And we know we have to run some loop while L is less than N, which is like and R is less than N. Only then, like till that, we have to run some loop. Fine. Okay. Fine. So we have to, and we have to take some like some scene element kind of dictionary. So let's take some dictionary, and we can take scene elements, or we can take a temp as well, like temp. Scene element is like some common word, like otherwise what you say, what is temp? Like it is not understandable. So we can see it scene elements. All right. Okay, fine. So first, what we will do, like as soon as we will run our loop, L is equal to 0, R is equal to 0. So what is our first thing? So our first element is at A. First, we are checking what is our current element. Current element is S of R, right? Because we will keep one element, and we will like we will keep one pointer same, and we will move our next pointer. So which pointer we are moving? R. So we have to check R only. So current element is S of R. So if current element, right, not in, because first we are doing the not in scene elements. If it is not in the scene elements, so what we have to do? If it is not there, we are going to increase our like R. All right. So R is equal to R plus 1, because we have to, if it is current is not there, then we are going to increase our R. All right. So we have increased our R here. Fine. And so now left is here, right is here. All right. So R is fine. And what is the length? So we have to calculate the max length as well. So max length, let's put the max length is equal to 0. All right. Fine. Okay. So, but before increasing our like right pointer, I have to store my A in the scene elements. All right. So I have to store my A in the scene elements. So scene elements of S of R is equal to R, because we are storing the current position. A is at 0. So now the scene element S of R is equal to 0. All right. And we will increase our right pointer, and we will keep increasing else. So let's suppose we will keep increasing, keep increasing, keep increasing. So R is going to increase, then R is going to increase, then R is going to increase, right? So now it come to the A. So A is already there, right? So if current element in the scene elements, if we found in the scene elements, if it's a scene element, then what we have to do? We have to shift our L, right? So we have to shift our L. So where we have to shift? So because first we have to check the previous location. So previous previous location is of scene elements of S of R. because right now R is at A. So let's pause here because we will earlier R is at A, then B, then C. So everything is in the if loop. It will keep increasing, keep increasing, keep increasing. Then it will R reaches at A. R reaches at A. So current element is A. We are keep checking like if, but this time it is not in this loop because current element not in the scene element, but current element is in the scene element because A is already there. So what we have to do, we have to increase our left pointer, but where, how much point we have to increase our left pointer and where we have to put our left pointer. So to where we have to put our left pointer, for that we need the previous, like current element previous position, like a is at like which position earlier. So previous location of A is as so far as the scene elements, right? And we are going to increase our, and like we have to shift our L, right? And how to shift our L? So max of current L, whatever is the current L, and L plus previous location. So basically, like earlier I said, we will only increase L plus one, but it is generally it is not L plus one because there are some test cases in which it is going to fail L plus one. So the safest condition is whoever is the maximum. So right now L is at 0. The next is 1. So L plus L, wherever is the L and wherever the previous location, we are going to increase that L plus previous location and we will put the R. And as soon as we put the R, so we have to store our this element as well. We will update our, because now we have increased our L. So now L is at you can say L is at B. So we have to update our, so we reaches here because we cover A, B, C, and like R is at A and is at A is already previous. So we are going to shift our like left element. So we shifted our left element, but we have to update our like index in the scene element. So we have to update our index into the scene element, and we are going to increase our R plus one. All right, and we are going to calculate the max length. So max length is equal to max of max length comma, so what is the max length till now? So R minus L plus 1, because index is starting from 0. All right, and we are going to return our max length. So let's try it if it's work or if there is any issue. So 3 5, so it looks it not working because output should be 3 and we are getting 5, so there should be some issue. Let's try to debug that, like what's the issue here. So scene element is empty, max length is 0, and okay, we are not increasing length, we are not increasing the length. So like R is equal to R plus 1, we are not increasing the length. Okay, fine. So let's try to figure it out. So we did mistake here, right? As soon as we find the previous position, we have to increase by one only, right? Whatever the next position and whatever the maximum we are going to store. And along with that, I noticed here, I am already storing the S of R current element. Then why I am putting S of R again? I can directly use that variable current element. All right. So let's try to rerun it. So now we are like able to like same output only. So let's try to submit it. And like we can even more optimize it. Like we will try to optimize it later. So let's first try to run it. Whether the solution is working or not. So 3 default test cases accepted. So now it's work. you could see now we beat 89% of the people. Earlier we beat only 15% of the people. Even though the previous solution also accepted, but we beat only 15%. But this time we beat all, like, just by using the two pointer approach. Rest everything we are using the same dictionary we are using, same the way we are checking, same the loop we are doing. Right? So we can like even more maximize it. How to more maximize it? So I could see here r plus 1 is here, r plus 1 is here as well. So why can't I can't put r plus 1 here only outside the both, because r plus 1 is going in both the loops. So I can like do only once uh, at a time only, right? And r plus 1, okay. Yeah, so let's try to submit if anything is right or wrong. Yeah, now we have 84 even. So yeah, that's it. Like that's the end of the video. So you can also try this question. Like generally, it's like a very common question asked in the interview question. So first method is brute force, which I think everyone can do is because we have to just run two loops as and we are calculating the length. So first is the like the brute force, just run two loops and we have to store the previous elements. We have to store because we have to check whether that element comes earlier or not. How to check? We have to store somewhere. The best way to store is the hash map, that is a dictionary. As soon as it will come, we are in and we are going to increase our length. The second way is because if we don't want to run, even though this solution is also accepted, but if we don't want to run the two loops, so the other solution is we have to run the two pointer approach. So we will run the two pointer approach and we have to like keep increasing only one pointer. As soon as we increase one pointer, we are going to check whether that element exists or not. If that element exists, then we are going to increase our left pointer. So here this part is little bit tricky. Like if we increase only like left is equal to like previous location plus one na, then there are few test cases which are going to fail. So the best way is max of L and previous location plus one. And rest everything is like same only, like we are keep increasing our right pointer as well. All right. So that's it. Like you can try. Thank you.